Alright, hell yes. We have physics, we have the 3-point NBA basketball shot problem, 40-degree angle. What's the velocity? And this is a long 3. So we use the equation for acceleration. Well, hell yes, the derivative. It's a change in velocity, change in time. And then to get position, the velocity is change in position, change in time. So you do acceleration of gravity is negative 9.8. We can integrate that, and here's an equation for velocity. At time 0, we got velocity initial, sine of the angle. That's going to be our upward component. Now the x, the velocity is just constant. There's no gravity. So then we integrate again, get the position equations. So at time is equal to 0, what's our position? I'm going to say the feet is the datum, so this is 0, 0. So we're up 2 meters in the y direction. Now in the x, it's just plus 0. We're at 0 in the x direction. Okay, hell yeah. So when we shoot the basket, the ball is going to get here in a certain amount of time. That same time is synonymous with 10 meters in the x and 3.05 meters in the y. So we set this equal to 10, this equal to 3.05. And then with both those equations, we got 2 equations, and now we're just left with, we got 2 unknowns. We don't know that initial velocity, and we don't know time. But we're going to say, hey, the time for that location is the same. So now we can just rearrange one of the equations and solve for t. This one looks good and easy. So I can just say, hey, t is equal to x divided by v cosine 40. This is x, and then I do it again and throw in the value of 10 meters for x. Hell yeah. So now I have an equation for t. I can stick that in to right there and there. So see how this becomes t squared, and then this is just the t. So it gets pretty big. So we're going to evaluate, again, this t is associated when this y is 3.05 and this x is 10. With that, 3.05 and this x is 10, that's going to be the same time, so this is how those equations, compile together. And there's no quadratic equation needed. We do have we will have a square, but essentially, first thing I do, 3.05 minus this 2, and then check out this. These velocity initials cancel, and sine divided by cosine, well, that's tangent. So this just becomes 10 tangent 40. So we have a bunch of constants, 3.05 minus the 2, and then minus the 10 tangent 40. Cool, and I'm going to do 2 steps at once. I'm going to divide. So now this is gone, and this is our constant on this side. Now I'm going to divide by 4.9. Hell yeah, did it. And that's going to be 10. So we want this initial velocity. We're getting pretty close. Now we're going to take the square root of this side. Hell yeah. And now velocity initials is downstairs, and we want that. So let's just take that upstairs and then this downstairs. That's all we did there. So we have 10 cosine 40, and then all that stuff came downstairs right there. And booyah, we have our equation for velocity initial. And we find that our initial velocity at a 40-degree angle is 10.665, whatever. But it's 10.7 meters per second. So that's the answer for the problem. And so here it is in the calculator, so you can see it twice, and 10.7, rounded to 10.7 meters per second. All right, hell yeah, under 4 minutes. Thanks for joining me. That's a video.